Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Is offline testing and power systems really safe anymore from cyber intrusion? In this episode of Energy Talks, I speak with Christopher Pritchard, who is head of product management at OMICRON, where he has been focused on improving the cybersecurity of power system testing devices. Christopher will describe hidden cybersecurity risks in traditional offline testing practices and how new cybersecurity tools are built into the latest generation of testing solutions, such as an OMICRON CMC 500 protection testing device, to make offline testing more cybersecure. Christopher has been a previous guest on Energy Talks to share his experience and insights into protection testing. Hello, Christopher. Welcome back to Energy Talks, and thank you for joining me for this episode about how offline testing in power systems is not truly secure from cyber intrusion and what is being done to change this.
Thank you, Scott. Looking forward to it.
Christopher, many engineers assume or have assumed that if they disconnect their test PC from the internet, the security of the substation is maintained. What's the flaw in that logic today?
Yeah, I know this is a super common assumption, but just because a test PC isn't connected to the internet, it doesn't mean that it's safe. At some point, the PC is going to exchange data with other systems, whether it's a test plan, instructions, scheme drawings, relay settings, all this type of data that we're exchanging. And if that PC has picked up malware somewhere along the way, it can absolutely carry it into the substation environment. It's like a revolving door, if you want to say so. And that malware doesn't need an internet connection to do any damage. It can sit quietly and spread laterally. So the idea that offline equals security just doesn't hold up anymore. Another thing I like people to consider is that also the test sets themselves are what we consider cyber transient assets. So they're not anymore dumb boxes, right? They're more like small computers nowadays. And if I connect my test set to the substation, also at that point it becomes part of the digital ecosystem, and therefore it is also a risk vector to the substation. So unplugging a PC might feel like a safety move, but in today's landscape, it's rather a false sense of security, I would say.
What are the potential risks when the test system is infected?
If your test system is compromised in any way, you're not just dealing with a glitch or a slowdown, you're potentially introducing dangerous behavior during testing. So that's the first threat I would see. That could mean it could trigger unwanted operation of the test equipment, for example, which could put field personnel at risk. It can damage expensive equipment in your substation, or it can potentially run some test routines that are accidentally tripping a breaker, for example, that is more than inconvenient, which can actually be dangerous. But further than that, where the test system doesn't behave correctly, also the test system could lead to the infection of your substation network. So it can act like a Trojan horse by opening a backdoor and to the substation network, and they're introducing a malware to that substation network.
Okay, so in a sense, it's something that's just waiting to get in when given access.
Correct.
Can you walk us through how an attack on the test system could take place during offline testing?
Yeah, absolutely. So first, there's different levels how likely attackers would approach this. And first of all, there's very simply something that's called information disclosure. That's when sensitive data between the PC and the test set, like, for example, configuration data, commands, or even passwords would get exposed. And once that information is out, it can be used to plan deeper attacks. So going deeper with our attacks, there's a very infamous classic man-in-the-middle attack. They say you're sending a test command from your laptop to the test set, and someone intercepts that communication. They could alter the data in transit, inject malicious commands, or even just observe what's happening to learn how the system works. Same would be true in the other direction, so whatever the test set sends to the PC. And finally, there could also be the direct takeover of control over the test set. or test equipment. An attacker could establish a connection to the test set directly. That means they could run unwanted commands and with that disrupt an operating substation, as we explained before.
I have heard OMICRON claims that the CMC 500 is the most secure protection test set on the market. How does the CMC 500 protect against such attacks?
One of the key pillars is a public key cryptography. We use it, for example, to encrypt all sensitive data, whether it's configuration files, test results, or firmware updates. Imagine it like a lockbox. The CMC 500 can create locks to share with other software tools. So, for example, in our case, with our test universe or whatever client tool there is. But it keeps the key to unlock it for itself. So the PC can now put its message, the configuration file, for example, in a box, locks it down, and can send it over a communication channel. And nobody who intercepts this channel can really read what's in this box. If it now arrives at the CMC 500, the CMC 500 has the key for this lockbox, and it can unlock the box and read what's in the message. So in other words, the PC receives a so-called public key and encrypts the message with it, and only the CMC 500 can decrypt it with the so-called private key. And that's why it's called public key cryptography. Then there's things like what we call authentication. By default, the CMC 500 identifies itself as an OMICRON device with a signed certificate. So it follows a certain chain of trust is the technology behind it in case you want to look it up. The signature mechanism uses, again, public key cryptography, and the PC can evaluate the certificate with a so-called chain of trust, as I said before. So by securing the connection with a password, we can even establish a mutual authentication, where also the CMC 500 only speaks to the authenticated PC, not letting any other PC take control of the test set.
Okay, interesting. So when attacking a CMC 500 from the outside is so hard, why would somebody not try to get the malware directly installed onto the device? And how would that even work?
That's actually a really good point here. And likely it's also how attackers will think today. So instead of trying to break the communication to the test set, which also requires you to be there when the communication happens, they might try to sneak malware onto the device itself, like through a firmware tampering, what it's called firmware tampering, via a compromised update. So, of course, we thought about this and implemented a secured and measured boot. That's also, again, something you can look up in the internet. It's a well-known technique here that we apply. And first, the CMC 500 checks and accepts only firmware that is signed by OMICRON. So you cannot just build a firmware and load it onto the CMC. It will check before if it's been signed by OMICRON. And during the installation, then even if you get past this or somehow you could get the signing, during the installation and boot up, it checks itself to make sure nothing's been tampered with. So if the firmware has been altered, it won't run. It's like a built-in lie detector, if you will. And even if someone did manage to sneak something in, the CMC 500 doesn't just let any code run wild. It enforces strict access controls, for example, via privilege elevation. So depending on what you're trying to do in the device, you would need different passwords and different access levels again and again. So making it really hard to make your way into the device.
Okay, so is such protection mainly a feature of the software or the firmware? For example, will all test sets have this functionality sooner or later when they receive a software update? Or is it more than that?
It's a little bit more than that. It's not that easy. Some security features can be added through software updates, of course, but the really critical stuff that we just talked about, the secure boot, the encryption, is really baked into the architecture of the device itself. The so-called Trusted Platform Module, TPM 2.0 as an abbreviation, is a physical component that is built inside the CMC 500. It's soldered on one of the prints inside the CMC 500. And it plays an important role when we come back to these private keys that we talked about, encryption. And as the word already suggests, a private key is supposed to be kept private. Otherwise, somebody else can open your box or can lock things into a box that they're not supposed to do. And Therefore, you must not save this key in plain text in the memory on your device. Somebody else could go on your device, sneak in, and read this key, and then suddenly they have access to the encrypted communication, for example. Or they can use it to sign maybe firmware updates and stuff like this. So the TPM chip is nothing else than a tamper-resistant chip with even physical security mechanisms to store these kind of private keys.
You mentioned the term public key cryptography, and then you mentioned the private key. Are they one and the same?
It's actually always a pair. The public key is the lockbox that we talked about. The public key can be used to encrypt messages, but only with a private key I can decrypt it again. So many people that talk to the CMC can encrypt a message with a public key, but only the CMC itself can decrypt it with its private key.
Very interesting distinction. Thank you for that. Okay, so as long as field engineers don't connect directly to the substation network, you would think they wouldn't need a test set with all these measures. Is that correct?
On the surface, I think that sounds reasonable, but in reality, I think it's a little bit more complicated. Most customers expect a test set lifecycle of 10 years or longer when they purchase today a test equipment. And let's be honest, many CMCs stay in service even much longer than that. So even if you're not connecting to a substation network today, nobody can guarantee that no one in your organization will ever connect it to a network in the next decade. Maybe by curiosity, just because there's a connection, you can plug it in, right? See what happens. Or an accidental connection, or because your organization purposefully is deploying digital substations. And now if you want to test a digital substation, what you need to do is you need to connect your test set to the network. So unless you can absolutely guarantee that your test set will never touch a substation network, it's a risk and it has to be considered in terms of cybersecurity. It's kind of like saying, I don't need a seatbelt because I'm only driving around the block and I never make accidents. It's a risky assumption.
That's a very good point. Christopher, what if there is a new malware the CMC 500 is not prepared for?
And that is a very important thought and a very good thought you have there. We talked about many measures we apply to make the life of the attacker harder. But of course, we have to accept that 100% security is ultimately unattainable. So when threats emerge, our priority is to respond swiftly and conscientiously. When we become aware of a vulnerability, we follow a well-defined process. Once we've confirmed the vulnerability, we assess its impact and the risk, and then try to develop a solution, of course. Our goal is anyway to always disclose any vulnerability in tandem with the security advisory, ensuring our users are not left exposed. Such advisories may recommend updating to the latest firmware. Hopefully that is often the case, that this is possible. But it could also be an advisory to close certain ports on your PC because they are an attacking vector for some reason. Now, these security advisories themselves, now users can look them up on a dedicated product security page that is available on our website and to remain informed about the current issues and solutions. And on that site, what I always recommend is, of course, always keep your firmware up to date. You can never go wrong with a CMC firmware update to have the latest fixes in your firmware. But of course, as well, you can regularly review the security page, or even better, subscribe to the so-called RSS feed that informs you when there is a new advisory.
Very good. Are field service engineers or system operators actively involved with that, or is it their IT or OT people who are looking at that all the time?
I assume that depends on the type of company you're working for. If you're a small service provider, a small testing company, I guess it will be on yourself, and you run the company, you do the tests in the field, and you want to subscribe to the RSS feed. In larger companies where they already have a thorough vetted cybersecurity process and responsibilities assigned for this, there might be dedicated persons that already demand certain information from us. In the very near future, this even becomes a necessity for every digital product in the market, that you provide this kind of information to your customers. It's part of the so-called Cyber Resilience Act in the EU, at least in the European Union.
Interesting. Thank you. You had mentioned that in this area, nothing is perfect. But could you safely assume that system operators don't have to worry about substation security anymore when they use the CMC 500?
Yeah, I know that would be nice, but sadly, I cannot say yes to this question. The reality is the CMC 500 can only reduce your worries when it comes to testing your protection system. So making sure that there's less of a risk on that attacking vector. It's a secure tool, but it's just one piece of the puzzle. Substation cybersecurity is a much bigger topic. There are regulations and standards that operators must follow. And beyond that, it's just smart to take additional measures like network segmentation, access control, intrusion detection systems, inventory or vulnerability management. And of course, always super important, employee training, awareness with your colleagues. Also there, OMICRON can support the customers.
Interesting. Christopher, can you elaborate on that?
Sure. Cybersecurity is not only a topic within our products, but also one that we address with our OT security solutions. OMICRON has its own tailor-made intrusion detection and vulnerability management system for power systems and industrial control systems, and it's called Station Guard. And if listeners want to dive deeper into this, OMICRON has some really good resources, and it's a dedicated website we have for this, and it's called omicroncybersecurity.com, where the listeners can find expert advice, training options, consulting services, but of course also information on the products and stuff that in general helps you build a solid cybersecurity strategy around your substation environment.
Thank you very much, Christopher, for sharing your insights and experience about why testing offline is not truly secure in this episode of Energy Talks.
Thank you, Scott. Pleasure to talk to you.
Thank you again. And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.